We know Mars is the nearest neighbor capable of supporting human life. Humans have been attempting to reach Mars for decades, and there are plans to begin living on Mars within the next decade. So, is life on Mars possible? Will humans ever reach Mars? If so, how will be the first year on Mars? There will be many aspects to consider before making such a large decision like moving to the Red Planet, and let's find out how is this going to happen. To accomplish the colonization of Mars, the greatest issue or limitation is the weight of the payload, spacecraft, personnel, fuel, supplies and so on that must be transported. We still believe that sending something into space is equivalent to launching a gold bar. The payload mass is typically a modest fraction of the launch vehicle's overall mass. The Saturn V rocket that took Apollo 11 to the moon, for example, weighed 3,000 tons. However, it could only launch 140 tons to low Earth orbit, that's 5% of its initial launch mass, and 50 tons to the moon, less than 2% of its initial launch mass. The size and capabilities of a Mars spacecraft are limited by its mass. Every maneuver necessitates the use of fuel to power rocket motors. Fuel is required to fire rocket motors in every move, and this fuel must now be transported into orbit aboard the spaceship. According to SpaceX's plans, the crewed Starship spacecraft will be refueled in orbit by a separately launched fuel tanker. This implies that far more fuel may be transported into orbit than on a single launch. Another issue which is deeply intertwined with fuel is time. Missions to the outer planets that send unmanned spacecraft travel complex paths around the Sun. They slingshot around several planets using what are known as gravity assist techniques to gather enough momentum to reach their destination. This saves a lot of fuel, but it can also lead to missions taking years to complete. This is not something people would want to accomplish. The Hohmann transfer is the most fuel-efficient route to travel between Earth and Mars because both planets have almost circular orbits. Without getting into too much detail, this is the process by which a spacecraft performs a single burn into an elliptical transfer orbit from one planet to the other. A Hohmann transfer between Earth and Mars takes around 259 days, between 8 and 9 months, and is only achievable every 2 years because of the different orbits of Earth and Mars around the Sun. A spaceship may reach Mars in less time, SpaceX claims 6 months, but it would require more fuel. Assume our spaceship and crew arrive on Mars. The next obstacle is landing. A spacecraft approaching Earth can use the drag produced by contact with the atmosphere to slow down. This enables the vessel to safely land on the Earth's surface, provided it can survive the related heating. However, Mars's atmosphere is roughly 100 times thinner than Earth's. Because there is less possibility for drag, landing successfully without some type of assistance is impossible. Some spacecraft utilized airbags to land, such as NASA's Pathfinder mission, while others used thrusters, such as NASA's Phoenix mission. The latter, once again, requires more fuel. It would be more expensive in terms of gasoline to accomplish it that way. Since the 19th century, when American astronomer Percival Lowell suggested that the channels on Mars were ancient canals created by intelligent extraterrestrials, the concept of living on Mars has been a classic of science fiction. NASA's Mariner 4 spacecraft performed the first Martian flyby in 1965, while the Soviet Union's Mars 3 lander became the first spacecraft to land softly on Mars 6 years later. There have been several successful trips to Mars since then, including the deployment of 4 Mars rovers, the now defunct Sojourner and Spirit, as well as the still operational Opportunity and Curiosity, and NASA's Mars Odyssey spacecraft, which created a map of the whole planet. NASA is currently preparing a human expedition to Mars for the 2030s. It's unclear where people would land on Mars for that mission, but for a future Martian space colony, you'd want a permanent base someplace in the low northern latitudes, according to Ashwin Vasavada, a deputy project scientist for NASA's Mars Science Laboratory. Mars, like Earth, has seasons because of its tilt on its axis, but it also has a second periodic influence due to its very elliptical orbit. When the globe is furthest from the Sun, the southern hemisphere is oriented away from it, resulting in far colder winters and far hotter summers than those in the northern hemisphere. If you lived in the northern hemisphere, you'd get around 7 months of spring, 6 months of summer, a little more than 5 months of fall, and just about 4 months of winter. A year on Mars is approximately 1.88 Earth years, and a day is somewhat longer than 24 hours. The average temperature on Mars is minus 80 degrees Fahrenheit or minus 60 degrees Celsius. However, temperatures can range from minus 195 degrees Fahrenheit, that's minus 126 degrees Celsius in winter near the poles, to 68 degrees Fahrenheit or 20 degrees Celsius in summer in the equator. Temperatures might also fluctuate substantially within a given week. Mars is around half the size of Earth in diameter and has a significantly thinner atmosphere with less than 1% of Earth's atmospheric capacity. The makeup of the atmospheres is also drastically different. Mars is largely carbon dioxide based, whereas Earth's is rich in nitrogen and oxygen. Mars's atmosphere has changed over time. Evidence on the surface suggests that it was previously warmer and wetter. Living species on Earth are responsible for a large portion of the planet's methane emissions. It is also the major component of naturally occurring hydrocarbon gas reserves, with volcanic and hydrothermal activities also contributing. Because of the important role that natural life plays in the generation of methane on Earth, the presence of methane on Mars has been confirmed. It's remarkable how little the concentration of carbon dioxide, CO2, and other greenhouse gases has to change to make such a difference in our climate. We have increased the CO2 levels in the atmosphere by a fraction of a percent since the 1950s, yet this is already producing major changes in our climate. This is because CO2 makes up such a little portion of the Earth's atmosphere. It is measured in parts per million or ppm, which indicates that there are a million additional molecules for every carbon dioxide molecule. It has a concentration of only 0.041%, yet even a little percentage change results in a significant change in concentration. Mars is a terrible place for human settlement. Various technologies have been invented to help long-term space travel and may be used for Mars colonization. The longest straight space mission is 438 days, held by cosmonaut Valery Polyakov, while the greatest time spent in space is 878 days, held by Gennady Padalka. For the Apollo 17 lunar landing, the longest period spent beyond the protection of the Earth's Van Allen radiation band was around 12 days. This is tiny in comparison to NASA's proposed 1,100-day mission to Mars and returns, which might take place as early as 2028. Scientists have also speculated that the environment of Mars settlements might hurt a variety of biological processes in humans. There are a variety of bodily side effects that must be reduced as a result of increasing levels of radiation. Furthermore, Martian soil has large quantities of pollutants that are harmful to human health. Gravity differences may hurt human health by weakening bones and muscles. There is also the possibility of fractures and cardiac issues. Current rotations on the International Space Station keep humans in zero gravity for 6 months, which is similar to a one-way journey to Mars. This enables researchers to have a better understanding of the physical state in which astronauts on a mission to Mars would arrive. The surface gravity on Mars is just 38% of that on Earth. Another big issue that we'll need to address is communication. During the half sol, when Earth is over the Martian horizon, communication with Earth is rather simple. Mars already has communications satellites thanks to NASA and ESA, including communications relay technology in many of Mars's orbiters. While they will ultimately wear out, further orbiters with communication relay capabilities will probably be launched before any colonization trips are attempted. So all the above stated factors lead to the conclusion that Mars travel might be possible but will be dangerous. Humans have a lot to research before we ever make it to the Martian planet. But one thing to keep in mind is that humans need to become interplanetary species. This is because soon we will run out of space for our population. But we will have to wait and see if we can make it to Mars. Check out our newest video on the screen, you will be amazed.